Welcome to the Air Power Airwaves, the Air Power Manufacturing Solutions podcast series where we talk about manufacturing issues that impact you. Welcome to another episode of Air Power Airwaves, the podcast that's gaining in popularity due to some pretty amazing people like this right here. I got Eddie Rhodes visiting with me again, and a first-timer, Paul Kelly.
Right.
Paul,
welcome.
Bring it in, man.
Good to be back.
I'm glad to have you guys back. So, you know, running the podcast here for Air Power and the Airwaves gives me the pleasure of bringing in people that I enjoy talking to regularly, Air Power. I've known this cat for a very long time. This guy I've known for about 8 years.
Yeah.
And when I first started, I was one of 2 people in filters, and you were inside sales. Now you're account manager out in the field.
Yep.
And I'm one filter guy. That's all I do for everybody.
You are the filter dude.
So I am the filter dude. So I took the place of 2 people. Okay. I thought it was going to be taking place of 1, but it ended up being 2 very quickly.
The captain of capture.
Captain of paint capture, yes. Yes, it's a captivating job.
It is.
All right, so what's the topic today? We are actually going to get into something that these 2 guys are experts in. Me, not so much, but I know a lot about it. I'm around it quite a bit in the field. And we're going to talk about how to choose the right spray gun or spray gun technology for your liquid finishing process. There are way more options than I ever thought were even possible. And when you're new at it, it's very daunting on being able to actually figure it out. It's not just the gun, right? It's the delivery of the paint. It's the delivery, the storage scenario. Where is it coming from? Is it being pushed or pulled? You know, what's happening? Is gravity playing a factor or suction a factor? Or pressures. So we're going to kind of go down that rabbit hole with you guys today. But first, if you are listening to this podcast, you can also watch this podcast on YouTube. Our YouTube channel is exploding. It's about the only way I can describe it. We've put so much content on in the last couple of years, primarily, that our visitors and our traffic is just shooting up. So there's a lot of really good material there. So go to YouTube, type in Air Power Inc. or Air Power Manufacturing Solutions, and you will find videos after videos after videos. And all of the podcasts are available on a visual video audio there. So welcome to this podcast. Again, account managers, Eddie Rhodes and Paul Kelly. Let's get this show started.
Sounds great.
If you have a question during this entire podcast, 1-800-334-1001, and you will find somebody very quickly that can help you. All right, let's talk about this. Let's go down this kind of methodically. Let's talk about some things that we have to know about. Questions that you guys ask when you walk into a plant. You know, there's a lot of questions that have to be asked before you figure out what's going on. So the first question that I can think of is what is this shop currently using? What are they currently using, and why are they using that? So I do know that the one common thing that you hear on a regular basis, if you ask why are you using this current setup, the answer is that's what we've always done.
Yeah, or that's what we were doing when I got here.
Yep.
The scariest phrase in my world is when you ask, why do you do it this way? Well, it's the way we've always done it.
Yeah, it is.
That's probably the scariest phrase I can hear in manufacturing.
But it sure does open up some major doors.
It's usually a great leading question.
But I also find sometimes, because I'm involved in the powder side as well and other applications, and it's true with everything. It's a true assemble, move, and coat, all three areas of air power.
Sure.
It's that thing of that's what it was. That's the way we've been doing it, or when I got here, and we've continued to do it that way. But I think at the same time, you're also, if they're willing to talk options,
Mm-hmm.
you can really show some people how to do things way better, potentially cost savings significance.
Well, when I go into a plant, right, and you hear this is the way you've always done it, I usually answer back, well, how do you get to work? I go in my car or truck. And go, okay, well, this for 1890, you'd ride a horse. You don't ride a horse anymore. Well, there's a more efficient way to get from point A to point B.
Right.
Let's just think about this. Let's go down that rabbit hole, and you might be doing it the most efficient way, or there could be a better way to do it.
Yep.
And let's just have that conversation, right? It could save you money, it could save you time, it could save you labor. It could be beneficial to you.
And I guess you need to find out what point B is. Like,
Right.
what are you trying to do? What is your overall goal?
What's your objective, right? Is it to make one part a day? Or are you trying to make 300 parts a day and you only make 20, right? Is
Good
there a goal
point.
you have, right? Are you trying to accomplish something?
Is there a bottleneck?
Correct.
Well, those goals may be different as you go up the chain in that facility, right? So the operator
much
may
so.
have, you got anything that weighs 2 ounces?
Yeah.
Because I'm hurting at the end of the day, right? Then you go to the line manager who's wanting production. Then you go to the EH&S, VOCs. Then you go to the plant manager, where's my payback?
Yep.
So you got a lot of different interweavings that we have to go through. It's not just at the line. We have to do a line audit, right, to learn.
Correct.
Then we start going up and presenting our solution or our possible change.
Very much so.
Going up the
And
chain.
how to implement that.
Yeah.
And I know some of the other reasons why people are using what they currently use is they may have had a vendor suggestion, an equipment supplier suggestion, or a paint supplier, coating supplier suggestion. And we've heard about deals that go down that are in the market sometimes. Hey man, you buy our paint for the next 5 years, we're going to give you what you're going to use to put it on. So some cases, but I don't think it's that many that are out there really.
No, well, you go old school days. I don't see this as much anymore, right? But when I started, you used to look at the technical data sheet, right? You get the TDS sheet, and if this were 1980, 1990, even in the 2000s, usually there was equipment called out on that technical data sheet on recommended spray, right? And it could be
the
a simple
fluid nozzle size, the
Yep.
air cap,
Yep.
the pressure, the everything.
If everyone's done their job right, we know that this setup sprays this material well. And I always took that as a great starting point. Like, hey, here's what the material manufacturer has tested on. So we know this works, right? Let's start with that. That can easily DQ some stuff, right?
But over time, technology changes. How many of these guns that we have that we're going to talk about today have gone through significant changes in the past decade?
Oh my Lord, so many of them, right?
Well, the coatings also.
True.
Yeah, true.
The coatings also.
And to speak to those TDSs, right? I don't know how many times I would grab a technical data sheet, look at it, and say, okay, here's your recommended spray equipment. Well, they haven't made that gun in 15 years. They don't make that pump anymore, right? Your end user says, well, I want to order this. This is what they say spray with. Guys, that doesn't exist anymore.
Right.
So then you got to take those recommendations and go, okay, we know that this technology worked. What's the new version of it, right? And is there a better mousetrap?
Or they can keep beating their heads over and
Right.
trying to find it on eBay.
Yeah, good luck finding that, right? That's one of my favorites. But since you said, man, go for it, bro. You'll find it. Good luck.
Oh man. All right, so comfort level is another reason why people use what they use. They've just gotten so used to it. It becomes a clock in, clock out mentality with the equipment. It's just they know how to use it. They know how to use it well.
And they don't get bad marks for the way the coating looks or what have you. They're doing their job. They're not getting in trouble.
They've dialed it in.
Yeah.
They know what they're doing.
They know how to use it. Yeah.
And I would imagine that that's probably one of the hardest things to change. That particular scenario is probably one of the harder people to change.
Without a doubt.
Mhm.
Right?
Because, you know, if you're doing something, you're doing it as well as you've ever done it, you're going to have to show something pretty significant for it to make sense for them to change.
Yeah, when you've mastered your craft, right? Yep. Your operator, end user, whomever it may be, almost performs a flawless execution of a task, right? Yep. They've mastered that, and the scariest thing for them is to change it, and maybe not be as good as we thought or as we once were, and it's perception, right? You know, maybe they think that I'm not doing as good of a job as I used to because of insert this piece of technology.
And in that case, I mean, there's really, in my opinion, you guys might be different, but in my opinion, the only way to overcome that one is to put the system in their hands for them to use on a production level application for days, if not weeks, to see if it brings them anything different.
Education and practice.
Yep.
Right? That's what it comes down to. It is our job to educate the end user, plant manager, operator, whomever it may be. You know, here is the best way to use it. I'm not a painter. I'll be the first one to tell you that. I don't have that skill. But I understand the process and the technology and the equipment, and I'll put it in your hands, Mr. Operator, to take that knowledge, right? And use your skill to perform your craft.
Absolutely.
Right? And turn out a great product.
Well, there are some customers who just blow me away at the talent level that they have on site. And one of them, and I don't know if we want to mention names or not, it's in Nashville. And they make guitars.
Oh, yeah.
And the custom work that comes out of a sunburst guitar or the staining around the perimeter, they do that all by hand.
And it's all by finesse.
They got the neck, and that guy's not going to likely change. You have to be able to bring something to the table to get them to change, because the look of that guitar has to match the next 3,000 that comes behind.
Yep.
Correct.
Right? So that's that.
And he's operating off of muscle memory to a specific weight of that gun. There's so many little intricate things in that process.
Noise, the air level noise,
how it sounds,
the trigger travel, how far the trigger travels. Could be something on the back of the adjustment knob, you know, of how far that goes. He just goes to a stop, or they feather. There's so many fickle things. I say this all the time, and it's the best analogy that I know. A painter, no matter who they are, male or female, is like a baseball pitcher. They're fickle. They got to touch your hat 3 times. You got to rub their leg twice before they throw a ball. Or they just idiosyncrasies that are unique to these guys. And don't mess with them. Don't change them, because it's going to mess them up, right? And they're afraid of that. To Paul's point, they're afraid of that. And we have to make them feel comfortable that we're not going to do that. It's still a half-ton truck. It's still going to pull your boat. It's still going to do whatever you want it to. It's just a tad different. Let's see what we can do to dial it in to make it so that you can do your job correctly.
That's right.
When you talk about painting, right, or spraying, I kind of look at it in multiple windows, right? There's production painting.
Yes.
There's a level of artistry to it. And what are you trying to accomplish, right? Do you want to make the same widget all day long and be able to tell no difference between I painted it at 10 o'clock, I painted it at 3 o'clock, I painted it at 4 o'clock? Or is there a level of artistry, right? If you're making guitars, you want them to look similar, but you also want them to be unique.
Have character.
Right. You don't want them to be the same, like we stamped them out on the machine. You want it to look like there is you want your end user to know that there is a level of human involvement that makes this one unique from the one made before it or made after it.
Johnny painted this one, I can tell. James painted that one, right? And if you're that guitar picker that's anal, you're gonna. I like Johnny's work.
There's that means something.
It does,
and it means something, and it shows something, right, to the owner of that product, right? You want to know that, hey, this came off the line on Wednesday the 5th, and I've been to that plant. I know the guy that painted it. He's on first shift, right? That's a detail that means something to somebody.
Yep.
You know,
when
versus
I took my tour of this facility, whether it's a boat or whatever, look at that, man. Yeah, I met that guy who does this. Put the interior in or whatever it is.
It's a level of, it's a connection, right? And it means
versus
something.
The world of cabinetry or furniture or fencing and railing. You're just trying to make sure you have enough paint on it to where the substrate is hid, and you have enough to withstand the elements that it's going to be exposed to.
That falls into what we're going to go into a little bit more in a minute, is that we have functional and decorative.
Correct.
There you go.
Codes, right? So you're going to do functional and you're going to do decorative, and they each require a different technology.
And that goes into our next subject that we're moving into, is what is your substrate? What's the quality mandate? What's the customer finish expectation? What is the film thickness requirements? The part life expectation? Where's it going to be installed? What does it need to hold up to? And then what type of paint is it? Is it solvent based, waterborne, plural component? So we have all these factors that go into the process of analyzing what the right gun technology is going to be. Not just the gun, but the delivery methods and whatnot. So
you can change delivery methods, right? Because if it's a big kitchen and you're circulating and all that stuff, and you got all the colors out here, and you turn a knob and you got color B or whatever, but really today, I think the most that the customer is going to get out of it, or an end user is going to get out of it, is what's the proper atomization technology. Because all we're doing is we're atomizing a coating that has to be deposited on any given part. So atomization technology is really where I would like to drive this home at, is atomization technology.
Explain atomization for those that just may not know exactly what it means, or what. We have a wide variety of audience, so let's describe atomization.
Okay, so when we have a spray gun and we have no air, it's a fluid stream straight out, right? So it's the gun's job to break that solid stream up into particles. And the quality of finish that you're looking for, A, B, C, A being automotive style quality, right, would be class A. The atomization has to be much finer, so my droplet size that's coming out of the gun must be smaller to present a smoother surface, right, and a more uniform surface. So atomization is simply taking a liquid stream, breaking it up into particles, and allowing them to disperse onto the
You do that with pressure, with a number of things. The analogy that I've always heard people explain it to very simply is the garden hose. You have your water stream coming out of the garden hose, and then you start to put your thumb on it, start applying pressure and closing off the top. You're putting pressure against that flow, and it doesn't have anywhere to go, so it starts to, it just starts to disperse through and escaping any route it can, and now you can water the whole flower bed without tearing up the flowers.
Right.
Similar analogy.
I always look at it very simplistically, right? And you're taking a liquid, you're pushing it through, you're using pressure and air, right? Take that liquid and make it a mist, right? And that mist is now atomized, right? And that mist has to go from, you don't want to just sit right out in front of you. It has to go to something. So you have to take that liquid, you have to atomize it, make it a mist, and push that mist onto the part, and make sure that it lays out nicely and is smooth and is uniform.
And you have to decide what pattern that's going to be in.
Do you need it to be a 2-inch pattern? Are you painting something small, or does it need to be a 5-inch or 10-inch, right? And how quickly do I need to do that? Do I have all day to make one thing, or do I need to make one of these every minute, right? That all means something. And how much material do I want to go on there? I mean, we'll probably get into that here in a minute, but as you're pushing that mist, how much is actually adhering to the part? How much is bouncing back? what's being captured in filters,
Yep.
right? How important is that to you? Do you want it to all go on the part, or do you okay with 25% of it makes it to the part and the rest is in the atmosphere, on the ground, in the filters?
Non-target.
Non-target. There you go. Right? Do you care? Does that mean something to you?
You want to hit
Is
the
it
bullseye?
expensive? Right? How much are you wasting?
It's like ammo's so expensive right now. It's like going to the firing range,
Poo,
and
poo, poo.
having
Yeah.
a box of
Right.
having a box of 50, and I'm only going to hit the target with 10. I don't know where the other 40 went.
You blew a lot of money.
That's exactly right.
You know, it's
Do you want to waste $200, or do you
and
want to say, hey, this was worth my
it's-
time?
all paint is not cheap, but
No.
some paint is ridiculous. You know, depending on what it is, just the prices are just crazy.
Yeah.
But it's high quality, it's high end, it's highly engineered. So get the right paint gun technology to utilize the maximum amount you possibly can from can or drum or tote or a plural component, whatever it is, use it up.
When you talk about paint costs, right? I mean, it could be $25 a gallon. It could be $2,000 a gallon, right?
Yep.
And how much of this do you have?
And
right?
how much are
do
you
they make?
wasting?
Correct, right? You know, I've sprayed some coatings that are $500-600 a gallon, you know, in production. Well, the numbers really start adding up. If you go, I'm using, you know, conventional spray and I'm only 25% transfer efficient.
Yep.
Well,
Do the math.
you know, guys, it's $600 a gallon.
Your paint supplier loves you.
Yeah,
Yeah, that's
the
right.
material
No wonder
guys
they
love you.
wanted to give you that free gun.
Yeah. You know, and
Here's some hats.
Right. And sometimes, you know, maybe the equipment they recommend or gave you is not the most efficient,
Right.
right?
In their best interest.
Correct. Who's it, you know, they may tell you one thing, and it's because they know it works. It's not there's no ill intent there, but
Yeah.
they know this technology works, but it may not be the most efficient.
Yeah, they also know the other technologies out there, and a lot of the paint reps are cognizant of that, and they want to lead you towards that direction
Mm-hmm.
in a common goal. But it all amounts to, we can't pick your spray gun for you. You can't pick your spray gun until we know and we land on a coating.
Mm-hmm.
The coating, and then all these other things that we're talking about, drives
It
your
dictates.
decision. It does dictate.
It dictates.
And,
right?
and it's logical, it's proven, it's known, it's industry best practice oftentimes. And sometimes your best practice isn't what is in the industry, it doesn't run the parallel line. It's like, everybody's doing this, but I'm doing that, and I've got a particular reason I'm doing that. I
Mhm.
may be painting the edge of that guitar.
It can be very specific, right? And when you talk about coatings, right? I'm an equipment guy. You're an equipment guy. You're an equipment guy. I'm not a material guy. I want to work with the material guy to help recommend equipment, and vice versa, right?
Sure.
Sometimes you may want to take advice from your coatings manufacturer, but that's not their world. Their world is liquid. My world is equipment.
Mhm.
You know, we have different knowledge bases.
Well, to your point about, it looks the same at 10 o'clock as it does at 2 o'clock,
Mm-hmm.
right?
Mm-hmm.
And most industry isn't conditioned as far as their environment.
Very
right?
much so.
So I start out, it's cool, or it's really cool on third shift. Might be a little damp on third shift,
Mm-hmm.
right? So waterborne comes into play there. So the coatings people have to try to help the end user pick tail solvents, right? To move that coating for the temperature that's out there and the humidity that's out there at that time, right? Either way, they're still going to be using the same gun. So we have to have a gun that has some flexibility with it at times
Mhm.
for pressure control, atomizing control, fan control, all those things go into play when they are altering their coatings. So you have to pick something that's fairly friendly, but still, you just give the operator a window to work in, and if you're outside of this window, something's wrong.
Yep. Hey, how much does the substrate play into the choice of your application equipment?
Good question.
You know, we can go down a list. I mean, we got what, plastics and ferrous metals, non-ferrous metals, wood. And in wood, you have MDF, and you've got
it's a whole nother
hardwood,
game.
a whole nother game.
Yeah.
Glass, plastic, Casts, fiberglass, FRP, fiberglass resin products,
Carbon fiber's coming on.
carbon fiber, fabrics and textiles that are sprayed. You know, there's a host of different things, and I would imagine some of those, you know, pressure or, you know, something that's being violently pushed towards it's probably not going to work very well.
But I mean, you look at it simply. You can coat anything. What are you coating, right?
And what do you
What's your
paint are
objective?
you using, and what's the substrate going to do?
Right.
How's
Simply,
it going to respond?
Simply, right? You know, wood versus metal. Wood is, every piece of wood is going to be different, and it's porous, and it
Right.
absorbs moisture, and different woods absorb more or less moisture, right? Particle board is like MDF is a sponge, right?
Yeah.
Atmosphere plays everything. If it's humid, it sucks up water. But metal, you got a sheet of metal, it doesn't really care if it's 20% humidity or 100% humidity, other than moisture may sit on it if it's very humid, but other than that, it's the same,
Right.
you know?
The only thing that I would say to add to that is if it's a large metal part
Mm-hmm.
and it got cool that
Mhm.
night, and or it came in to your shop cool,
Mm-hmm.
it's gonna make a big difference how that coating lays on there, right?
Oh, yeah.
In the hang, you know, versus
Yeah.
running, right?
Oh, yeah.
And you're doing everything perfectly, you've got a heater in line,
Mhm.
and it's the same pressure, it's the same fluid pressure, the same air pressure, the fan pattern, everything looks beautiful, your cc's per minute coming out, it's just perfect, and it sags. If it's a new gun, your equipment don't work.
Yeah.
And it's not that, a condition changed, right? So hopefully, this is important for you listeners and viewers. Work with your coating supplier to nail all that down, and then if we need to, we'll spray your stuff in our labs. We've got a couple of labs, we'll spray it in the lab before we bring it out to your facility and make sure that we dial the process in. That way, you're not putting out bad parts going down the line.
Fair enough. You know, medium density fiberboard, I was just thinking about this too. You know, that's actually something that's also powder coated.
Mm-hmm.
And with powder coating, you're not really responding to an electrostatic charge with the wood. You're heating the wood.
Mm-hmm.
You've got an application that way. Now, you do get some electrostatic application here.
Yeah.
Because it's the amount of moisture that the board has in it. And anybody who sprays MDF board with powder coating, there are meters that stab into the board.
Oh, yeah.
And those boards are supposed to be stored in certain environmental rooms with a certain level of humidity,
Mhm.
certain level of moisture, because when that part goes into the powder coating process, all the edges are usually sanded down nicely,
Mm-hmm.
and the only way you can get good edge wrap is the moisture content in that wood is actually part of that electrostatic property.
It works the same with the electrostatic liquid on wood.
So there,
Mhm.
therein lies an issue with something like MDF board. If the MDF board is dry, super dry, relative, you know, little moisture, versus at whatever 30% or whatever the moisture level should be. Obviously, you don't want 100% moisture.
Right, yeah.
You won't have a board anymore. But let's whatever that level is, to give it those electrostatic properties for edge wrap and coverage. Those are things you got to be aware of.
That process it's not a unicorn process, but it's so rare for me to see because there's so many variables that come into play.
Yep.
It's about doing a repeatable process. There's so many variables that have to be consistent all the way through to build a repeatable process to get a quality finished product out the door.
And I've been asked this question a ton, like, can you powder coat hardwood? I'm like, yeah, you can.
Sure.
But it's probably not going to look very good. Well, why is that? Because, you know, at 400-degree cure time, resins don't like to just stay in place. They kind of like to bubble out.
Right.
So there's just a lot of defects. But anyway, that's
It's
a
all
little off
doable,
subject.
right? It's all doable.
It's
It may
all
not be
doable.
cost effective.
But what we're trying to say is whatever the substrate is, we have to know all the parameters of what's going to be going on. You know, is your shop in Michigan and you're having trouble with stuff that was sitting outside that you pulled in and overnight let it dry off and then you're spraying it, but it's still cold as ice, versus a plant that's in Florida, summertime, that's spraying fencing and railing, and they have no problem at all. I mean, it's just done.
What, where, why? What are you doing? Why are you doing it? Where are you doing it? You know?
Yeah, it is.
It seems very basic, but that's just some simplistic questions to ask to get a good understanding of what you're doing.
Or where are you at right now and where do you want to be?
Correct. You know?
So these guns, again, you know, some of these technologies I would imagine that we're going to go through. I would imagine a big part of your decision process is how much paint do you go through? What's your current volume of paint that you go through? And you guys we were talking about this earlier about you kind of like to know what do you go through per week, per month, you know, per year, or go day, week, month, you know, as basics. And a lot of customers know pretty well what they go through in paint per day or per week. And if they don't, there's some other questions that need to be taken.
Somebody somewhere in an organization knows how much paint they use.
Well, I would imagine purchasing is going to know.
When in doubt, right? In our world, most of the time you start with the painters, or supervisors, right? And they can give you a good idea or a baseline of how much paint do you spray a day.
Right.
But some of them don't know. When in doubt, go find the purchasing guy, because he knows how many POs he cuts. He knows how much money he spends, right?
That's
The
right.
painter may say we spray 2 gallons a day. The purchasing guy says, well, I'm buying 300 gallons a week.
Yeah.
You know, okay, what's up here? Who's telling the truth? You know, purchasing guy knows.
Yeah.
He's not going to BS you. He
Yep.
knows how much. He knows how many POs he cut and how much money that was, and the accountant knows too.
Oh yeah.
He's writing a check. She is writing a check, right?
Now, paint comes in all kinds of formats, you know. You go to any store and you get it from little, you know, little tiny things all the way up to, you know, paints and stains and little sample things, up to totes, all the way to totes. And which
Get
are
in tankers if you want it in a tanker truck, you know.
Back when furniture was running hard, 1,000-gallon, 1,500-gallon lacquer tanks and varnish tanks, and
Yeah, I mean, I'm sure there's probably still some niche markets that use, you know, tankers of something.
Yeah, those guys
lacquer
still
or
exist.
paint.
They're not as prevalent as they used to be, but they still exist.
Yeah.
And it just comes into buying power, right?
Well, but it's still where the rubber meets the road is when it comes out of the gun.
True that.
Right, and that's really what we're trying to drive towards to help our audience is which one of these do I pick?
Yep.
Right.
Let's go down that rabbit hole. All right, I'm going to pull this back a little bit. We're going to set up this area here to kind of be able to set whatever gun we're talking about. So the guys and I got together ahead of time, and I have a list of guns, and I'm going to start from the top and work our way towards the bottom of those guns, and one by one we'll talk about them. What I really want to challenge you guys with is let's talk about each gun. Let's talk about what methods of delivery that gun requires for paint delivery, or what will it work with, okay? And maybe markets that the gun is a winner in.
Prevalent.
Yeah, and if there's something that we're talking about where that gun should absolutely never be used in a certain application, let's touch on that too. All right?
Kind of try and keep it short and sweet. What is it? What does it do? How do you get from point A to point B and out the gun?
Yep.
Right? Just here's your cut sheet on it.
That's it.
Let's start here.
So if we, as we're going, if we define some kind of parameter as we're going, let's just go for it.
Oh yeah, okay.
All right, the first one, and I don't even know who they've decided off camera. I don't know who's taking what.
Yeah, there you go.
Yeah, Rochambeau. So I'm gonna say AIRSPRAY.
Yes. I have
Winner.
AIRSPRAY. Chicken dinner.
All right, Eddie. What does AIRSPRAY stand for? What does that mean?
Conventional spray.
Okay.
That's the oldest technology. Dr. Alan de Vilbus invented it in the late 1800s,
Okay.
right? Which was like a little perfume
Like a puffer.
Perfume
but
puffer
he did
atomizer.
it being a doctor for atomizing stuff to go in the back of the throats and up the
Okay.
nose and stuff.
All
So
right.
that's where atomization came from. Our modern atomization. Anyway, that's been used forever. That's what everybody sprayed with. It'll spray darn near anything. It'll spray adhesives, it'll spray stains, it'll spray waterborne, it'll spray solvent based, it'll spray really heavy coatings, it'll spray zinc, right? If you're spraying zinc, know this, it's gonna wear out parts left and right, Because it's abrasive.
Yep.
This is the technology that wins in zinc.
Okay.
Right? This particular gun is pressurized, but it could be siphon or it could have a gravity on top, which stands true for a couple of other spray guns that we're going to show you. But this is the best atomization, right?
Mm-hmm.
But the worst transfer efficient.
Okay.
There you go. Right?
The velocity, Paul touched on it a little bit earlier, the velocity of the material coming out of this gun is much faster, much greater than a Hvlp gun or an LVMP gun or other atomizing technology.
So in other words, if it's not directly hitting the part, it's gone.
Well, it's not going to obviously turn and come around because it's not electrostatic, but it has so much velocity, it hits the substrate and bounces off.
Oh, okay, all right.
Right, so if you're putting out 40 cc's a minute, then 10 cc's might be sticking to the part.
Right.
So
And the rest of it is bouncing off.
And this is a gun that you're probably not going to get up close and personal with a part. You're backed off a little
10
bit.
inches or so.
Yeah.
That's probably normal. This is 8 for me, and I always say about 8 to 10, something like that. Sometimes 12, depending on how wide of a pattern you need, because this pattern comes out this way, right? It's this type of pattern. So the further you are away from it, but you can get out of the properly atomized sweet spot, and now it can be dry spray when it starts to hit the part, because you may have some really fast evaporating solvents because of the weather conditions or the way your paint's formulated. So target distance does play into it, but this easy to maintain, lots of air cap choices, lots of fluid tip and needle choices. You have the ability to control the fan here, how far the needle travels here. Some guns, this one, particular one doesn't have it, has a built-in cheater valve under here, right? So that we can cheat that air. We don't know what that pressure is. If we're trying to hold a certain pressure, we don't know what that pressure is. But if you are a wood shop, a plastic shop, and some metal shops, and you are NESHAP compliant, which stands for National Emissions Standard Hazardous Air Pollutants. Wow. Yeah.
Mouthful.
Pretty good.
Yeah. So if you fall under that category, this is something that they frown on. This has to be used less than 5% of your coatings.
Okay.
Mm-hmm.
Right? They want you to move to a better practice, best practice, lower emissions gun, which would be higher transfer efficiency.
So that would kind of go into the category of oldie but a goodie.
Absolutely. If you can't do it with this, quit.
All right. Next, we are going to move to HVLP, which is high volume, low pressure.
So, when we look at this gun, it's a different color gun. Notice that, right? Same body, different air caps, different fluid nozzle. It has more holes in the fluid nozzle so we can get more air through it. Pardon me. Get more air through it, which would help increase our volume. So high volume meaning higher CFM usage, Low pressure, meaning low velocity of the material coming out to the part, so we have less bounce back. So it
Okay.
increases your transfer efficiency, right? The issue that we had with these guns when they first came out years ago, when niche-out became prevalent in the wood industry, and they were mandated to go to HVLP, was that they didn't atomize as well at production speeds, turning it up, right? And then they found that once you turn it up so high in pressure that you get about the same result as you did with a conventional gun, right? So these used in their, and it says HVLP on there, and the cap will say that too, but if they're used in their proper environment, they're dialed in properly, this technology will save you paint.
Okay.
Higher transfer efficiency. It's going to look the same, weigh the same. You can get the full-size version like this. Some have bubbles in the back, some are flat, some are smaller than this, some are heavier than this, depending on the brand that you choose. But you get into being able to choose the technology, then pick the gun, the tip, the air cap that matches your production speed, and the size part that you're spraying, right? So, but this technology is really well grounded now. It's in place. It's considered most of the time best practice for most applications that you go to that can't use other technologies,
Okay.
right? For coating purposes or substrate purposes. Then we move to,
Which one is that?
LV.
Oh, the LVMP right there.
And
on
I
the
only
gun.
know that because it's written
Yeah.
here, right?
Yeah.
Because it looks like the
It's
same
kind of
darn
shaded
gun
when
as
I'm
this
looking at
one.
it from this side. All the light coming here.
But it's just the same gun, but again, the technology is different. The air cap technology is different. The way the material comes through here and the air comes through here is a little bit different. LVMP stands for low volume, medium pressure. So what I get there is comes from Europe. Europe, believe it or not, drives a lot of our technology.
They drive a lot of compliance too.
They do. And some of our, say Graco, for example, their name of their gun is compliant.
Yep.
Right? Where this is a Binks gun, it's called LVMP, low volume medium pressure. And Iwata calls it the same thing, LVMP. And what we're doing is we're taking conventional spray atomizing quality, reducing the velocity, increasing the transfer efficiency. So the LVMP is a great hybrid between conventional spray and HVLP because you still get high transfer efficiency out of it.
Okay.
But if your finish quality needs to be high, this is a better choice for me than HVLP because it provides you smaller droplets, which is what your atomization is, right? So that technology's there. This is a little bit smaller gun, as you can see, compared to the standard size. So if you have the need, you can have a smaller gun. They're out there.
A smaller hand or a
Smaller hand. Female operators, female painters are probably the best painters that are out there because their eye's better, their color association's better, and they just have a different feel for applying the coating and seeing the coating and what the coating's doing. But we have a variety of choices for all these methods, right? And knowing, digging in, letting your account manager work with your team, answer all these questions that you're going to get bored answering.
Yep.
Or you may not want to go and find that answer from a painter standpoint. So we may need to move around in your plan, but get that information and then we can pick something out that we can pretty much prove out what's going to work before it gets here. But our whole goal is one, to reduce weight on you if we can, and that could be through fluid hose, air hose, sizes, picking the right one, pick the right diameter to match your speed of production on the fluid nozzle, and then pick the right air cap to produce the pattern that you're looking for. Some patterns are blunt ends, right? Some patterns are really fine tapered ends. Depends on what you need.
Yeah. Some patterns are round spray, right? And something else just to touch on is when you talk about those three technologies right there, typically you will see them sprayed at quote unquote low pressure, right?
All this is low pressure
It's
technology.
all low pressure technology. And low pressure being, in my world, I always say low pressure is like 100 pounds and under.
Yep.
Right? I think what can move it? A diaphragm pump or a pressure pot?
Yep.
Something 1 to 1. So usually plant air is 9 times out of 10, everyone's got 100 psi plant air, and usually you're going to be using air. Well, historically you'd be using air to power whatever vessel is going to be pushing the paint. As we advance into, 2022 here in modern times, electric is an option, right?
Yeah.
In the implant world, but typically you're going to be spraying those at low pressure, and usually 10 pounds, 20 pounds, 30 pounds, 40 pounds, 50 pounds of pressure will move a lot of coatings, right? Until you get into the thick stuff and just need more oomph to push it out the gun.
Yeah, higher solids.
Mm-hmm.
Well, speaking of that oomph, it's your turn. You've got
Okay.
the oomph on your side. So you covered compliant, right?
Yep.
Mm-hmm.
Yep. So we're moving to airless.
We're going to go airless or AA?
AA.
Let's go AA. You talk about an AA gun. It's air assisted airless, right? So we're using pressure to atomize the coating. And the air portion of that is really just to shape that pattern, right? And wrangle it in, finesse it, get some work on the tails, taper it up, and just have a nice finish quality. And when you talk about air assisted airless, I've run air assisted airless as low as 250 psi. And you can just kind of go up from there, right?
Yeah.
Do you want 1,000 pounds, 1,200 pounds, 1,500 pounds, 2,000 pounds? What's it take to move that coating?
It's coating driven.
It's very coating driven. It's also more efficient than your
All of
traditional-
these technologies are less efficient than this.
Correct. I used to use, just to make it easy, I always say that your low pressure guns are probably 25% transfer efficient, maybe 30% transfer efficient at best, which means 25-30% on part, rest, it's somewhere else.
Off target.
Off target. These guys, 45-50% transfer efficient. Would you say that?
Yeah, and if we're painting plywood sheets, even
It gets
higher.
better. It gets better.
It gets higher. Yeah.
Very, very coatings driven, very application specific, very substrate specific, right? You just gotta get in there and see. But with these guns, oftentimes you find they're smaller, they're lighter, and they're a joy to use. You see that one's got no needle travel. We've locked that out.
Well, that's a good point there. But what happens with air assisted airless and airless is, folks, you can't feather that. There's no feather. You pull the trigger, it's all or nothing.
Mm-hmm.
It's on. With this technology, the low pressure technology, you can barely pull the trigger back and get a little coating, or you can pull it fully back and get a lot of coating.
You're finessing it.
You finesse. That you don't.
This is on or off, and when you hear air, right? I've run this gun specifically as low as 4 psi on the air.
Yeah.
Because we need just a little bit, and whether you're spraying like that,
Mm-hmm.
or if you're doing a tabletop, you might be spraying like that.
Yes.
And that air plays a factor in your bounce back, your transfer efficiency, right? If you're spraying like this,
Yep.
Your coating wants to go to it's gravity, right? It's trying to fall.
Yeah.
But if you're spraying like this, well, your bounce back is bouncing off and up and being pulled down or back. But
Depending on your booth, right?
Depending on your booth, right?
Yeah.
Depending on airflow.
Yeah.
Is it a
Is it
downdraft
behind
booth?
you?
Is it going that way?
Yeah.
Is it going that way? Is it going that way? Or is it going down?
Right.
All those factors come into play.
The thing with that is this, if we're talking energy,
Mm-hmm.
you talked about that, and I'm sorry to interrupt you.
No, go for it.
When you talked about compressed air, right? And we see that as an expense, a very large expense.
Very much so.
Pretty much the highest expense electrically that the plant uses is their compressor, a lot of times. So low pressure technology uses more air, AA uses less air, so not only is it more efficient transfer wise, but it's cheaper to operate because of it uses less energy.
Very much so.
Right? So you're moving in the right direction here. But if you have to feather something and be detailed, It's a little harder to wrangle that one.
Well, you know, something else to think of while talking on that, when we talk about pressures, right?
Right.
And you're talking parts, and furniture's a good one, wood's a good one for this example, right? You've got 20, 30 pounds coming out of that.
Blowing a light part.
There you go, right?
Yep.
You know, so if you've got them on a hang line, we'll go old school and say you've got that
You're
guy's
pushing
floating
it.
down the line,
Yep.
right?
Yep.
20 pounds probably ain't gonna swing a heavy piece of wood, but
But it might a little lightweight piece of
200
plastic.
pounds,
Yeah.
300 pounds,
Yeah.
400 pounds of pressure coming out, all of a sudden, well, now my part's moving.
Yeah.
And how's that affect your finish quality? Well, now you're literally trying to hit a moving target. Sometimes it's moving like that, now it's moving in and out.
And if it's on a swivel hook, have you turned it by
God.
starting on the edge?
Right, you know, is that part blowing, is it rotating, is it swinging, right?
Right.
Factors, it's all about the factors and variables in your manufacturing process.
Yeah.
Okay, well,
All right.
that ends the AA portion of this.
One thing we didn't touch on
Yes, sir.
with that is the tip drives the width
Mm-hmm.
of the pattern.
Impingement. Impingement is what's really atomizing this.
The cat eye.
Mm-hmm. And you won't be able to see it, but you can get in there and look and see just that little teeny tiny orifice, and it's a cat eye shape. That's the best analogy you'll ever get. Going to complete airless technology. No air driving this. Pure pressure, right?
All hydraulic atomization.
Mm-hmm. You've got a variety of different tips, right? Most times, well, every time you want to see these dog ears, whatever, on here,
Oh yeah.
because you've got pressure. And when you talk about airless, it's on up there. I mean, you're spraying 1,000 plus usually to see atomization of this.
And that's the one that is the danger zone for people.
It is.
Oh,
You know,
yeah.
you have to be very knowledgeable and sharp when you're using that technology.
You need to be vigilant, right, and take care of yourself, because you think about this, you've got 1,000, 2,000, 3,000 pounds of pressure, sometimes more than that coming out of this gun. If your hand is there, well, it's going to inject you with paint.
It's
So
just
there's-
like a pressure washer.
Mm-hmm.
When you got
That's-
you're washing your sidewalk, that's what kind of pressure you're
Yeah.
talking about.
I mean, it will.
That's a trip to the emergency room.
Yeah, for those of you that have not had the pleasure of sitting through training for some of these things, I remember some very distinct photos that were shown in one of the training classes
Yeah.
that I sat through with this particular technology, and it was some pretty gruesome stuff.
Very much so.
And it's because you can really get hurt, dead hurt with this technology. You've got to know what you're doing. And this is truly a sign when you see it. It's pretty universal the way it looks in the different technologies.
Mm-hmm.
And it's a warning sign and kind of an obstruction of to be able to put yourself in that way.
I mean, you gotta.
And but you know, it'll not just inject you, but it'll do a whole lot more damage. It'll shred you.
I saw some of those films.
Yep,
It'll scare the bejesus out of you.
no doubt.
It sure will.
It's like
an
when you-
injection here, but they cut them up to here
Mhm.
to get rid of it because it backfed, if you will.
It's like those
It's like a snake bite. Right.
it's the high school. So you want to get a driver's license training, class where you have to sit through the video and watch all
drunk
the.
drivers and yeah.
It's one of those types of videos, and I'm just telling you, if you look into this technology, just be very well aware that training for your team or for yourself is going to be at the utmost importance.
When you talk about a safety factor, there's two things you really look at. One, visual indicator. Don't put my hand here. Two, trigger lock, right? If trigger is locked, so
No trigger lock.
no trigger lock.
Low pressure, no chance of injection.
Correct. You're changing tips, you're doing that, you want to lock the trigger, and you really want to kill the pressure to it. I mean, that's just safety 101 here.
Yeah.
But it's little things like that that says, hey, this could be dangerous. If there's a safety device on there, that means, hey, pay attention, guys.
Yeah, that's not like the trigger on the gas pump that you can trigger it to hold it on.
Mhm.
It's a trigger to hold it off. Safety to hold it off.
And I'll say, when you talk about in-plant manufacturing, when you see true airless technology, it's usually not fine finish. It's usually not super high quality. I tend to see more airless in thicker coatings,
Yes.
abrasive coatings,
Yes.
and in applications where we need to coat it, and we need to coat it fast.
Well, that's the reason why this gun says contractor on it.
Mm-hmm.
So all your painting contractors, a lot of them,
Yes.
will spray with that and back roll it.
Mm-hmm.
Because they can get more paint out there faster, right? Or trim, what have you.
Yep.
And you don't have to have this air. When you finally atomize something, drift outside is going to become a car polishing, sanding,
Mhm.
or repaint.
Mm-hmm.
That's expensive.
Mm-hmm.
That's terribly
Mhm.
expensive. So the bounce back can be real, but there's no air to carry it away. So the transfer efficiency is pretty high on that stuff.
Yeah. And contractor, right?
Yeah.
Contractors could be working outside.
Oftentimes.
We're not painting a kitchen cabinet. We're painting a building, or a ship, or a crane,
Large pipe.
Brick wall.
brick wall, right?
Yeah.
You're painting typically large areas, large surface areas in unique environments, in ever-changing environments.
And it's heavy.
And it's heavy. It is. They're bricks.
And,
But-
but they're made to be robust and to take an abuse and keep on ticking.
They're thrown around. There's less that when you look at this gun versus any other gun, there's just less stuff on it. It is a brick. You're either going to have a tip in there like you would with AA, or you're going to have one of these reversible tips, right? Because those coatings that we're spraying are thick, abrasive, nasty, sometimes 1K, sometimes 2K. And contractors, right, you spray a wall, what do you do with the gun? Well, you're not going to flush it. They just lay it down, prep what they need to, you come back, well, my tip's clogged. With these, you're able to turn it around, blow that booger out,
Yep.
flip it right back around,
Go to work.
get back to work, right? Because time is money.
Paint boogers.
Yeah. I mean, that's what it is.
That's what everybody calls
It's an
it.
industry term.
It is. It is.
You heard it here on Air Power Airwaves. Paint booger.
And then we'll jump into electrostatic.
Electrostatic.
Electrostatic guns, this is probably going to be a Paul and Eddie back and forth on this one. Electrostatic guns come in a variety of different fashions, right? Here's a low pressure AA gun. They make an air assisted airless electrostatic gun. You get rotary atomization bells, that's ESTAT,
Mhm.
right? Corded, non-corded,
Mhm.
turbine driven.
Yep.
Manual, automatic, all these guns, you have the options of manual guns or automatic guns. We won't dive into that too deep, but
Even to the point of adding them to a robot, the end of a robot.
correct. You can, sky's the limit.
Sure.
What do you want to do? But electrostatic technology, low pressure, we'll keep it simple with this. Your highest transfer efficient technologies of the things we've shown you. I would say 65 and up is usually what's published, I think.
Mm-hmm.
There's some variants, right, depending on your environment, depending on your coating. It's very important to make sure you have and waterborne electrostatic.
We better run down that rabbit hole a little bit.
You want to run down waterborne, or you want to talk?
Let's because of their coating is making us choose the equipment.
There you go. Okay.
We can't take a solvent-based electrostatic gun and use it for water.
Mhm.
Gotcha.
It will hurt you.
It will ruin your day.
You just can't do it. So they need to know that.
Waterborne, right?
Yeah.
When you're charging a part, water is extremely conductive, and you usually have to isolate your material supply in a waterborne coating. Usually in the form of a stand or a cabinet, something with a grounding rod, because when you charge what's coming out of the gun, it's an aqueous solution, so that charge goes all the way back to where it began.
Mm.
So now you have a electrically charged
Vessel.
or vat of liquid, and if you don't ground it, well, when you touch it, it will bite you, and it will hurt. And it is a hard
lesson.
It's a hard lesson, and it's
And it
really,
does hurt.
It does hurt.
I've been the recipient of it.
I have too.
It hurts.
And it's a concept that's kind of hard to explain and make sense. You almost have to learn the hard way. I mean, I had to learn the hard way, and you remember it, you know.
Yeah, but we don't want your operators to learn it that way. It effectively, you have to isolate the fluid supply, like Paul said, and the thing that there's a little bit of difference, slight, of solvent-based to water-based or waterborne electrostatic, is we want to bleed that charge off very slowly coming out of that vessel, right? Because, like you said, he said aqueous solution. So as you go back to the vessel, right, it starts that charge there, and then it comes back. So that has to build up a little bit, but so we slowly bleed it off.
There you go.
There's some voodoo there.
They're
That's happening behind the scenes, right, that we take care of. But just know that you have to pick this for water, or you have to pick it for solvent. You can't go back and forth in between them.
It's one or the other.
Yes.
The other thing, we'll kind of jump all around on this, and when you get into electrostatics, it's a conversation.
It is.
And there's so many moving pieces to this to understand. And not being scripted, it's hard to run through the list in order. But you're charging a particle. You're not charging the paint, you're charging the air around the outside of the gun. As your liquid moves through it, it becomes charged, right?
Yeah.
And it's super important to make sure that you are grounded, and you need to make contact with this handle. I can't tell you how many times I've been in a plant using electrostatic technology.
Plastic gloves.
Rubber gloves.
Rubber gloves.
Rubber gloves.
I'm getting
Right.
shocked.
That's my number one
Why is it
complaint.
arcing?
You know, I get shocked every time I put this down, and you go, well, are you touching? Yeah, I'm touching the gun. And you look at them, they have a glove on. I said, no, you're not touching the gun. You're holding the gun, but you're not touching the gun.
Yeah.
You have to cut a hole in the glove. You just need to make sure you make contact with the gun.
Yeah.
Because you're the best ground.
Why
You
is
are.
it getting on me?
Right, you're the best ground. You're made of water. And arcing's a good one. You know, you don't want to see a spark come out of this.
Pop, pop, pop.
Yeah, you know, you see a spark coming out. Remember, it's a flammable liquid. Sparks are bad.
That's a flamethrower.
Yeah.
It could be. It's a potential flamethrower. If
Potential
you don't take all the precautions.
Well, when you flush up, when you clean it out, right, and you're flushing solvent through the gun to make sure it stays clean, because most of the time it's a 2K material, and once you've mixed one component and another component, all it wants to do is cure and become hard. That's its job, is to go from a liquid to a solid, and it's going to do that as soon as you mix the two together. It's like pulling the pin out of a grenade. There is a time limit on how long it stays a liquid.
That's a good analogy. Yeah.
I use it all the time. But when you flush a gun, you're flushing with solvent, and it's very important to turn your air off on a non-corded gun to make sure that you don't have a flamethrower as you push solvent through.
Electrostatic has to be off.
It has to be off, and you can turn it off on the back of the gun, but you make sure that you disconnect the air that spins the turbine inside of here, so there is no charge coming out, because you don't want a flamethrower. And I've seen it.
Yeah.
I've seen it, and
It'll ruin your day.
it'll ruin your day. It's quite entertaining to watch if you're far enough away.
I've not seen it real.
I've seen it a couple of times in person. It's fun.
I've had a couple of customers that it's happened to.
Capture video next time.
I will. You use phone's not
There's
the
no
first
time.
thing you're grabbing.
There's no time.
Seeing a flamethrower come out of the end is right up there with a spontaneous combustion for me.
Yeah.
I've had the pleasure of seeing a couple of those too, and
But
check marks.
so that gun is really good for people that have very large metal
Or small.
substrates.
Mm-hmm.
That they're having to spend a lot of time traveling around the substrate as they're painting it.
Mm-hmm.
Because in those cases, you've got your booth is so big,
Yeah.
you know, and it just works really, really well. Or even you hear of people using the electrostatic liquids when you don't have a spray booth and you're touching something up in the field, or you're doing
number 2
something.
gun.
The Ramsberg
two.
number 2. Do they sell a modern version of the Ramsberg number 2,
Same
or
as
is
the
it still
50s.
the old?
Same as the 50s.
The Ramsberg
I have
number
video
two
of
is the
me
Ramsberg
using
number
that
two.
using that gun, but you know they use that for like lockers in gymnasiums.
Office
They'll
furniture.
in office furniture in the office.
No overspray.
No, it's like 98% transfer efficient.
Yeah.
You want to paint a fence in a field and only paint one side because it wraps, that's your guy. When you talk about these, I'll use a customer of mine. They were using conventional spray technology, painting large beverage trailers. So they're big metal rectangles.
Yeah.
Big 20-foot, 30-foot, 40-foot, 50-foot metal rectangles. They use conventional spray technology.
What was their payback, ROI?
It saved them dollars.
Hmm.
It was $250,000 a year ROI. They were about $1 million a year paying customer. That's dollar value. I won't get into, I can't remember gallons.
Yeah, but still,
But-
it's tremendous, right? This
was-
is considered best practice.
So you talk about the dollar value ROI, it saved them $250,000.
Yeah.
When you talk about the payback on this, I did an ROI calculation based on the cost of the gun, how much material they saved, how
Yeah.
much their material cost, the time they saved by switching to electrostatics, because it's more transfer efficient, which means more paint went on part, which means they got part coated faster.
Well, it's typically 30% faster on average.
That's exactly what it came down to in a time study. But
That number holds all
it's
the time.
true. But payback on one gun
Yeah.
was
A day.
I don't remember it in days, but it was 0.01 months. It paid for itself in about a day.
Mm-hmm.
Is what it saved. One day, it justified the cost of it. They needed 4. It paid for itself like nobody's business. They were able to increase production because they were able to paint a body 30% faster. Their bottleneck was no longer paint.
Yeah.
It was how long it has to sit in the oven to cure.
Right. So then you can change paint technology and speed that up a little bit possibly. But the main ingredient there that we're missing, that could be the driver, why do you need to look at paint gun atomizing technology, right?
Yep.
Is that they may have been up against their window on their VOC permit, on their spray booth permit. And then I can't produce any more parts. I can only produce 4 trailers a day because I'm bumping my limit on my permit.
If you are a very aware, and when I say aware, environmentally aware company, and have a good environmental department,
Stewardship of the environment.
there you go, and you track your VOC emissions and you're towing that line.
Yeah.
You could be just chugging along all month long, making production, making your 4, 5, 10 units a day, whatever it may be, and you get to the last 3, 4 days of the month, and we can't make anything. We can't get parts out the door. Why? We're not allowed to spray. And you don't want, as a manufacturer, if you're not making something, you're not making money.
If it doesn't go out the door.
If it doesn't go out the door,
Yep.
you don't want to have them staged up, sitting in line, not able to ship, not generating revenue.
Right.
And electrostatics may be that, right?
They
It
may
may
be
be
your
that saving
hero.
grace.
Yeah.
And say, hey,
Hero.
well, now we can paint more.
Yeah.
Why? Because we're more efficient. We're using less paint and making more parts.
Right.
And we're saving dollars. We're saving time. We're helping the environment. You know.
It's actually a better painter environment, so there's less overspray in there,
Correct.
right?
There's less overspray.
My visibility
The
improves.
operator.
My spray booth exhaust filters are reduced because there's less overspray coming to them. Everything's just better with this.
It's almost this is the most challenging piece of technology to capture a true ROI on for me, because there's so many variables that come into play and so many benefits that go along with electrostatic technology. Not for everybody. There are things you have to do to make sure that you are prepared for electrostatics, and steps you got to make sure the part is grounded. That's hard for some people.
Yeah.
Just remembering to do it is hard, or they don't care. If you don't ground the part, your transfer efficiency isn't there. But you save time, you save material. Now you go down the rabbit hole of, well, if I start spraying electrostatically and more paint is getting on the part and I'm more transfer efficient, what's that do downstream for me? Well, maybe I change filters every day. Well, now I don't need to change filters,
correct,
but once a week or every 3 days. And most people view filters as it's just a cost of doing business.
It's a necessary evil.
It's just a cost of doing business.
Yep.
And it's a dollar. They don't think about buying them anymore. They just buy them. But if you have a booth that houses,
It's consumable.
It's a consumable item. If you have a booth that houses a 54-foot long trailer and that's what you paint, well, I bet you have more than 2 filters in there. You usually have a whole floor of them or bank of them, and we're talking thousands of dollars to
Right.
change these things out, and the time to do it, because it's not a 5-minute job. It's a lot of heavy truck booths I see are usually downdraft booths. Disposal costs.
Reallocate my labor from doing this into making sure my gun's really clean, my pumps are maintained, my filters have been changed in my fluid stream, right? I can reallocate those hours and do something else with it, right?
Well, I would say in a lot of smaller, not smaller, but a lot of small to medium-sized manufacturing plants, right? Well, the guy who changes the filters in the booth is usually the guy who's holding this too.
Absolutely.
So if he's not spraying with this, and he has to stop production to change filters in the floor.
And the higher frequency of changing of filters, the more you need to have on site, and storage is always an issue.
Yeah, I was thinking of that a second.
Storage,
Always.
shipping, right? You got to get them there.
Shipping and storage.
And they go hand in hand,
Cost
right?
eaters.
Freight's going down, isn't it, with all this gas stuff?
Well, right. It's cheap to ship filters too, because we're moving air, right?
We're being facetious, folks.
There you go. But does it make sense for you to buy a tractor trailer load of filters at a time? It would be the most efficient way to purchase them, but where do you put them? Do you have space for a tractor trailer at your facility that you can just store air in? Sometimes yes, sometimes no. Well, if the answer's no, then I gotta buy these, 2 change outs worth at a time.
Yeah.
Shipping costs will eat you alive on that.
Right.
Yeah.
They're expensive to ship.
All of these things we've just talked about is why this is considered best practice.
There you go. It's as simple as that.
Best practice. Can we spray electrostatically on plastic parts? Absolutely.
Yep.
Have we been able to do it on wood? Absolutely. Look at your situation, let a good account manager work with you and determine what's your best method. The thing that we didn't tell people is the kV, the voltage, right?
There you go.
This happens to be an 85 kV gun, which is the longest version. Here it is compared to a standard gun. So it's a little bit bigger. It's not really that much heavier because it's all plastic. But we also have a 65 kV or 60 or 65 kV gun, brings it back a little bit, and then a 40 kV gun, it shortens it up even more.
Yep.
Say you've got to get into a bunch of areas, I can get that short gun, still get 40 kV benefit out of it.
Well, they make that 40 kV booster that really has the
it goes to 60.
It's really a 60, right?
Yeah.
And when you talk about this goes down to operators, right?
Yeah.
If they're using that, they're used to that gun. Moving to this, well,
changes their target to tip.
it changes everything for them. It's a larger gun.
Yeah.
So a lot of times you can go with that 40 kV booster gun, and it's more comparable in size to what they're currently using, and you don't run into the objections, right?
And you
From
still
them.
get the electrostatic benefit.
You get all the benefits. Actually, my end user who manufactures trailers uses 40 kV booster guns for that reason. We didn't see a huge difference in transfer efficiency between 60 kV and 85 kV. They really like that shorter size. They have some funky areas they got to get in and move. You got articulating doors. You got to get under. You got to get up and in.
Yeah.
So that shorter size didn't mess with their target distance. It's a little bit lighter. You know, if you're holding a gun all day out here, it does fatigue your shoulder, right?
Sure, right.
Especially the older I get, the harder this gets. You know, especially if you're doing it for.
Wait till you get gray hair.
I'm
It get
terrified.
worse. It
I'm
gets
terrified.
worse.
But you know, it's just the little things that just add up, and it's tailoring that solution
Correct.
to the end user to make it fit their process, their application, their desires.
Yes.
Right? I mean,
Yep.
I got to get you what you want. You know, you may not need an F-350 Super Duty.
May not.
You know, F-150 is just fine and does everything you need.
Yeah. A Tacoma may do it.
Exactly.
Right. Just. Yeah.
All right, I'm going to bring it in and close this out because we are right there on the tail end, and the three of us could talk all day.
Oh yeah.
Okay, so Paul, thank you
you.
very much. I appreciate you.
Pleasure being
Eddie,
here.
thank you very much. And a couple more things, just keeping up with what we need to make you all aware of. Air Power Airwaves, airpowerairwaves.com. You can find this podcast there, video version. Air Power Airwaves can be found anywhere that you listen to podcasts. So if you're watching this one, you can listen to the podcast on the run. You can go to Buzzsprout, where we host, or you could go to Stitcher or anywhere, Spotify, anywhere that you listen to podcasts, have at it, and you'll find us. Just search Air Power Airwaves or Air Power Inc. or Air Power Manufacturing Solutions. 800-334-1001. If you have a question on any of the gun technologies that you saw today, or you want to talk to either of these superstars right here, you just call 1-800-334 and ask for Paul or Eddie. I did that right? Yeah, Paul or Eddie. It's weird when you're looking at
I know, it's totally opposite.
You can ask for them by name. They'll be glad to take your call. You can ask for me, but I'm not going to be as much help in this area as they are. Airpower-USA.com is all things air power. Coming up soon, hopefully by the time this posts, we will have an incredible web store live. We're eagerly waiting that. And I want to close this out with a thank you to all of you for watching, and remember to manufacture it a great day.